Hello, today we're going to be going over the phylogenetic tree. I will be explaining the reason I have constructed this phylogenetic yarn tree the way I have. But first, let's go over the definition of a phylogenetic tree and some key terms. A phylogenetic tree is a hypothesized diagram that represents evolutionary relationship among organisms or objects. So today we're going to be looking at the relationship between yarn. Anagenesis. Anagenesis is a change over time within a lineage. And cladogenesis is the splitting of one lineage into two. We're going to see numerous examples of cladogenesis in this illustration. Operational taxonomic units, also called OTUs, could be anything we're comparing, not just species. It's a term used to classify groups of closely related things. There are two types of phylogenetic trees, the rooted tree and the unrooted trees. In this illustration, I am going to be showing a rooted tree, and in a rooted tree, we can figure out the distance between organisms and when they had a most common recent ancestor. So basically, when they diverged. This is also a rooted tree because we have an outgroup, which is the fiber yarn, and the outgroup is the earliest OTU to diverge from the other OTUs, so the most distantly related to the other OTUs. The internal nodes are where more than one branch meets, so here I have denoted that with the white yarn on the branches, so that's where the nodes are. To determine the most recent common ancestor of OTUs, we can look at the phylogenetic trees, which I'm going to do later in this video. Now I'm going to explain how the phenotype works out in this phylogenetic tree. So to start us off, I have labeled the nodes on this phylogenetic tree to make it easier for you to understand what I'm saying. At the first node, the yarn either evolved to be a fiber yarn or not. Then the wool yarn branched off from the yarn that are made of wool. And on the third node, the yarn either evolved to be hand-winded or not. And then on the fourth node, the yarn that didn't become hand-winded either became multicolored or colored. And then on the fifth node, the yarn either became chunky or not chunky or normal. So on the sixth node, the chunky yarn evolved to become burgundy or pink. On the seventh node, the normal yarn evolved to become acrylic or velvet. And then on the eighth node, the velvet yarn evolved to become gray velvet or mustard velvet. The most common recent ancestor for the gray velvet and the mustard velvet yarn is at the eighth node. The gray velvet and the mustard velvet yarn are also the most closely related OTUs because they have the least differences and have the shortest branch on the phylogenetic tree.